I did a graphic for anyone who can't who or doesn't understand the shapes that we're seeing in these videos that I'm doing, and I'll get to that in a second. First, I wanted to go over this little bit of evidence that was omitted in my last video, and it has to do with the movement of this dome the subject that's in question. And I used this shape in the foreground as a reference point. The camera was moving a little bit, but not enough to impact this to any great degree, considering its distance. But this line right here is where the dome originated and came up. You can make out the beginnings of its shape right there, and the bright white says it's right in this area, and this is the outer edge of it. We've got the same thing in frame 12. Same thing. The outer edge. See that bright white spot right there? You can still see it in frame 13. Now, if that were part of the shock wave, if that were formed by the shock wave, we would necessarily see it moving to the right. It's not moving. Some might say, well, it's moving towards us. That's why it doesn't appear to be moving. No, it can't. This is the center here. This is moving directly towards the camera. This is moving anything to the right of center and center of the explosion is moving to the right, to the viewer. So this would have to move to the right. It doesn't move at all. That's proof that this dome of vapor was there before the shock wave got to it. The shock wave did not form this dome right here. Now, to help understand visually what we're seeing, I've got this diagram, and of course we have the blast, and these two circles represent the shock wave, frame 12 and frame 13, and this is that vapor dome that's in question, and this is basically our line of sight. The line of sight is everything in seeing the shape of the dome, and this illustrates that. This wing over here appeared behind this shape right here. This is the shape of that dome. It's like I have a hard time describing it, but it's like a nodule that sticks out ahead, and it's a small arc, and it's coming out ahead of a much broader arc behind it, which is the shock wave. And this edge over here, where my cursor's pointing, is the line of sight where you're looking out here just to the right of this little dome, looking just to the right of it, and you're seeing the edge of that shock wave come out, and you're seeing the very inside of it. End. You're seeing this end, this edge right here is what you're seeing. You see that? So it's important when talking about the vapor that in order to see the shape of the shock wave, you have to see the edge like that. When you're looking straight on, you really can't see the shape of the shock wave. Here we can locate it in space. We can see in the shape that from this view, this line of the shock wave is behind this shape right here. It's behind it. And the two sides form this shape right here, which is the larger shape of the shock wave. Now, if this dome were formed by the shock wave, again, it would have to move out. Now, it's important to understand how a shock wave moves. The shock wave moves just like a wave in the water. The water doesn't move. The shock wave moves through the water. Same with the shock wave in the air. Uh, the shock wave is moving through the air, and it accumulates vapor right behind it. And very shortly thereafter, that vapor evaporates again. It disappears. So the vapor that's forming is right behind the shock wave, and then it disappears. So it depends on the conditions of the air where you're going to see uh, the vapor develop. So if you're looking if you're looking straight into the shock wave like this, you're going to see uh, splotches of vapor forming in different places, and it's not going to you can't make the shape of the shock wave out. But when you can see the very edge of the shock wave, you can make out the shape of it. And that's one of the ways that we know that this original dome is sticking out. And you're looking back behind here and seeing the edge of this larger part. And uh, the fact that it doesn't move is final proof. It stays in the same place that it originated. This is coming out behind it. You're seeing the far edge of the shock wave over there. And this dome still has its shape because the shock wave hasn't fully reached it yet. Here you can see it's come uh, from frame 12 to 13. You can see the shock wave must be right about back in here, and here it collides with it right here, and you no longer have a dome. You have because it's come in and removed this back part of it back here, and that has now become more the shape of the shock wave. And it looks like it's more standing straight up, but you can still make out this shape out here, which has not quite been hit by the shock wave yet. This definitely hasn't. So the fact that this hasn't moved, if that's part of the shock wave, this has to move. There's just no other alternative. And from frame 11 to frame 12, it clearly doesn't move. I know some people may argue with me here on this, but I can see it. That's still the line right there. You can see the line, but just these two frames here is proof it hasn't moved. It stayed in the same place. That can't happen with the shock wave moving. It's going to continue uh, out. It can't sit still like that. So that's proof. I hope I hope this diagram helps anyone who doesn't understand quite what we're looking at. Um, this is a like a nodule sticking out. You can see it plain as day right there. Thanks for watching.